Hello, good day viewers. In this tutorial, we are going to find a solution to this double absolute value inequality, which is the absolute value of x minus 3 greater or equal to the absolute value of x plus 1, then minus 2. All right, let's get started. Let us create our intervals by finding the zeros of these two functions. If you set this one to be equal to 0, it implies x equal to 3, right? Because it is only if x is equal to 3 that this function will be equal to 0. Then by setting this one to be equal to 0, it implies x equals negative 1. So because negative 1 is less than 3, we are going to begin with negative 1. So our intervals will be from negative infinity way down to negative 1 exclusive. Then the second one will be from negative 1 down to 3, including negative 1 and excluding 3. Then the last interval will be from 3 down to positive infinity. All right. So what will happen to this function, which is the absolute value of x minus 3, if we should replace x with any value within this interval? You see, all these values are negative, so the whole of this will be negative. So we have the negative version of x minus 3. What about this one? All these values less than negative 1, we have negative 2, negative 3. Anyone you replace here, that will be negative. So we have negative x plus 1 as well. Then moving to the other interval from negative 1 down to 3. All these values are less than 3. Therefore, this will remain negative, right? So we have negative version of x minus 3. What about this one? Any value you choose from negative 1 down to 3, plug it in here, this will remain positive. For example, negative 1 plus 1 is 0. If you take 0 plus 1 is 1, 2 plus 1 is 3. Therefore, this will be positive x plus 1. Then the last interval from 3 to positive infinity, all these values are positive, greater or equal to 3. So this will be positive, likewise this one. So we have x minus 3 and x plus 1. So we have these conditions. So let's start with the first one, which is this. It implies that this is greater or equal to this, then minus 2. We are going to consider them to be negative. So if we have negative x minus 3 greater or equal to the negative of x plus 1, then remember we have minus 2, which is right here. So let's solve this. This is negative x plus 3 greater or equal to negative x minus 1, then minus 2. Let us bring this one to the left and take this one to the other side. As this crosses over, it becomes what? Positive. So we have negative x plus x, which is 0, greater or equal to. The moment you take 3 to the other side, it becomes negative 3. Negative 3, negative 1, that will give us negative 4, and negative 4, negative 2 is negative 6. This is negative 6. So you can see that 0 is always greater or equal to negative 6. This statement is true. So it means that x belongs to the set of real numbers from negative infinity down to negative 1. So x belongs to the set of real numbers here. So now let us take the second condition here. Negative x minus 3, negative x minus 3. This is greater or equal to x plus 1. X plus 1. Then remember, we still have minus 2 in the end. Let's expand. We have negative x plus 3. This is greater or equal to x minus 1, because 1 minus 2 is minus 1. Let us collect the like terms. As you bring this one to the left hand side, it becomes negative. Negative x is negative 2x, greater or equal to, if you take this to the other side, it becomes negative as well. Negative 3, negative 1 is negative 4. You divide both sides by negative 2, and this will be less than or equal to positive 2. Remember, the direction of the inequality will change whenever you divide or multiply both sides of an inequality by a negative value. So we have x less than 2. Is x less than 2 within the interval? This is the interval we have. Yes, it is within that interval. x less than or equal to 2. Then the last interval would be when we have both of them to be positive, that is x minus 3 greater or equal to x plus 1. Remember, we have minus 2. Taking x to the left, it becomes negative. We have x minus x is 0 greater or equal to. As this crosses over, it becomes positive 3 plus 1 is 4 minus 2 is 2. But 0 is never greater or equal to 2, so we're going to discard this solution. So where do we have solutions? We have solution between negative infinity down to negative 1, considering x as real in that interval. Then we have from negative 1 down to 2, because you know that 3 is greater than 2, so we are going to consider this one. So our solution would be x belongs to the set of values from negative infinity way down to negative 1, union from negative 1 down to 2, right? I think 2 is included as well, yeah. But if you unite them, it will be what? From negative infinity down to 2, because you can see that we have negative 1 at the boundary. So this is equal to, well, let me say x belongs to the set of values from negative infinity down to positive 2. And this is said to be the solution to this problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.